trying to show you a little bit is what we do and what are the services that we provide here, just around the corner in UCD. So, if this works. Yes, it works. So, in any kind of process, any kind of industry mechanism, etc., it's always the same process. You want to understand something that is happening, and you will go through several process where some of these components where biology is involved. You have to work with genomics, you have to work with proteomics, and you have to work in all the interactions between cells. So these are clear examples, like the disease that you described, like asthma or cancer. They have a lot of genomic components around that, but also a lot of proteomics. So you have the genes producing one particular disease, and that's driven by the proteins. If you look at how everything is going, around 90% of the diseases has a genomic component. If you look at how the analysis is done nowadays, and you compare them with a few years ago, you can see a big exponential increase about the knowledge of the genes. But also you can see that the cost of that analysis is dropping down year by year. And in the last few years, it has dropped down dramatically. Nowadays, if you want to analyze DNA of one particular sequence, it's less than 10 cents. If you want to analyze the full genome, your own genome, it would cost around 1,000 euros, and it's going lower and lower. But it's not just about the genes, it's not just about the proteins. What you want to do is genomics and proteomics, but this is kind of a mix. You put all your cells together and you analyze what they have, what they're doing. You know that you have the proteins, but not all the cells will produce the same information. And that's why you want to look at the imaging, how my cells are interacting. And the pictures that you will get, they're fantastic. Everyone is familiarized now with these images of cells. But it's more about how this is moving. What is the information that we have? So my cells, do they have this particular protein or they don't have that protein? Where is it located within the cell? How does the lack of my protein affect the physiology of my cells? Is this affecting the other cells, the surrounding cells? Is this affecting the full organ, or is something that we can skip and we don't care? Which ones are the mechanisms that could be altered after the production of this protein? Are all the cells produced by my proteins? Which cells are producing my proteins of interest? And why all these cells are producing? And what happens if they don't produce them? So we don't look at one particular cell. We have to look at the interaction between cells. And if we follow up these cells, as you can see here, not all of them are the same. You might have one cell that is behaving in a different way. So if you see and you track this over time, you can see that after one additional stimulus, this particular cell didn't react. And then you have this one with a higher reaction, some other intermediate. So all those cells are completely different. So what makes that particular cell clearly different than this one? Which one is the gene that makes them different? And that's why flow cytometry takes place. We'll look at thousands of cells per second. How we will do it? We basically put them isolated. We color code them based on the target that we want to analyze, and then we run them through our flow cytometry, which is basically source of light and some detectors for those colors. And then we quantify that really, really quickly. When I say quickly, we are talking about thousands of cells per second, with more than 50 parameters at the same time measured and analyzed at the same time. So we can get all that information and say if your cells are alive, if your cells are dead. You can see that the death is quite complex, so we can analyze different targets at the same time. We can analyze all the cascades and all the reactions. But it's not just that information. You go to one lab, you learn how to do it, and you try to follow up. And especially with the PhD students, they are the ones doing that job. So they finish, and they are the experts in one particular one. They go to a company, they are the experts using flow, imaging, genomics, and proteomics. But in reality, they're not experts. They have used that tool. So when you give them that same analysis, and you tell them, okay, give me the information, they will analyze in the best way that they can. But doesn't mean that it's the correct way. This is not correct analysis. because they have forgotten a few things, and the data looks absolutely different. But it's not just in research, it's also happening in diagnosis, and that's a bad thing. If you look at the number of publications in flow cytometry, for instance, you can see that this is exponentially growing up. But as much as they go up, lots of them are wrong, because they have been produced by experts, that they have no idea what they're doing. So a bad education in any of these fields ends up in a bad publication and has a huge impact. But it's even worse when it's a diagnosis, and it's a bad diagnosis. When we look at instruments that you have on your labs, mostly the instruments in Ireland are here, because that was when we had the boom and we have money to buy new equipment. But look at the difference nowadays. We are down here, so we could do things much cheaper and much faster. Fantastic. So I'll apply for that and try to get those fundings, to get that money. Those instruments are not cheap. They could be $500,000 to several million euros. But you get the funding. Okay, perfect. What will you do then? You will buy the best instrument in the market. Okay, I have a few companies selling that. Oh, I went to a conference and I found this one. This is super cool. Look at the design. Design is important. Looks nice on my lab. I can sell it to my funding agents. Is this the best instrument for you? Okay, let the expert to decide for you how to spend that money. Are you happy with what they got? Not always is the same. Because it's a more expensive one, is the best one. Not true. So you can see that you have fluorescent microscopy, electron microscopy. You have mass spectrometry, there's another one, genomics, optical microscopy, theory, PET scan, high content screening, imaging screen, cell sorting, laser macro dissection, high content, light imaging. You can see all those technologies that are quite correlated. And if you have to hire one particular expert for each one of them, you have to spend a huge amount of money. Okay? Now, that's where the core technology takes place. What we have in the core technologies is a group of people that are really experts in each one of those technologies. What we will do is you come with your problem, we discuss with you the project from the beginning to the end, and we'll start to select which one is the optimal instrument for you, for your application. We'll go as well into the sample preparation. Not all the samples are prepared in the same way. Not all the tissue are the same. Not all your cells are the same. So we want to get you the best out of your samples. Then we'll optimize your protocol. We'll analyze the samples with you on that particular instrument, but we will also go through the data reanalysis, how to get the maximum from each one of your samples. And finally, you have to sell this instrument. You sell that by showing and preparing the data presentation in a PowerPoint or a poster or whatever. And then we'll review again your project. Where you are now? Where is the next step? Where do you want to go now? So this is what we are doing. For instance, next week we'll run one of these courses. So it's not a course just for the people in UCD. We are working for the government, so anyone can access to our technology, anyone can access to our courses. So these are hands-on with experts from all around. I was talking to him before. We have people from Trinity as part of the instrument, of the instructors and coordinators. So we just not provide that training on site. We can go to the company and work directly with the company. We can sign up any kind of documents, and privacy is there. So in this case, we'll even go into the Netherlands and discuss with them what their projects are and what's the best solution with them. So if you see what we are doing, we work a lot with, obviously with UCD, but also with other academia and other companies. So where we are now, we are working with different fields, cancer, botany, immunology, but all of them, they have something in common. They're working with DNA, GFP, proteins, whatever. But it's not just at the university. We have them in industry, in hospitals, and research, and we work with huge amount of groups. What we have is a huge amount of information about who's doing what. We know who does what. We'll try to put them in contact. We'll try to make those connections, the networking that sometimes you need. So we are playing an important role there. So it's not just to know how, it's to know who is doing it, and try to use the right tool to decide the best thing for you. And as we are trying to point out we are not working alone, we work with another universities, and also we are trying to go into the hospital, as she has mentioned before, we are trying to go into the diagnosis. Let me talk with the doctor and see what's the problem, what they want to find, and trying to create those bridges based on the diagnosis. We want to make sure that the patient is properly diagnosed. And that has the other two pillars, is research and is education. And with these three pillars, we can start to build up the next step, which is the previously presented, which is basically design new tools, new technology that help us to diagnose and treat your patients cheaper, faster, and better. Obviously, we are working also with companies, and we try to create those links because they will help us to move into that direction again. And we have beta test and develop all these instruments in the past. So as I said, we're trying to establish the core technologies as the core of the research in Ireland, working with as many companies, as many providers, and as many groups as possible. That's it. Thank you.